I was working on part 2 of the history of rovers. I decided to ask my son, my oldest, my 6-year-old, how big does he think the Mars rover, the Curiosity rover, is? And he came up with this exact replica out of Lego. It's not too bad. Camera on the front. It's pretty cool. And this is about the size that he thinks it actually is. Maybe the size of a shoebox, he said. Maybe a little bit bigger. He was just as shocked as I was to find out that the real rover, the Curiosity, is bigger than my car. Bigger than this thing. It's taller. It's 7 feet tall. Bigger than my garage. And that's amazing that we launched a thing that's bigger than my car all the way to Mars. That's incredible. So let's find out more about that and Pathfinder and a bunch of other modern day rovers today in part 2 of my series on history of rovers. Hello and welcome to Space Course. When we finished part 1, we had just discovered the success of NASA's Viking landers. NASA then turned their attention to Earth orbit and its newly commissioned space shuttles. But on July 4th, 1997, NASA landed the first ever mobile rover on the red planet Mars. The Mars Pathfinder mission placed both a stationary lander and a small robotic rover on the Martian surface by way of an untried and new soft landing system that relied on parachutes to slow the spacecraft down, as well as a casing of airbags to allow it to bounce and roll to a stop on the Martian surface, hopefully upright and operational. Though designed to right itself in emergency, the spacecraft happened to come to a rest right side up. The lander then deployed the rover and both proceeded to outlive their operational lives several times over. The lander by 3 times its designed lifetime of 30 days, and the rover by 12 times its designed lifetime of 7 days. From landing to the final transmission of data on September 27, 1999, the Pathfinder mission delivered 2.3 billion bits of information back to Earth, including more than 17,000 images, 15 chemical analysis from soil and rock samples, and a myriad of weather and atmospheric data. It was incredibly useful to future Mars missions. Pathfinder provided the strongest evidence yet that Mars was once warm and wet, and inspired the design of future Mars missions that would follow, and also helped mark Watney off the planet. So after the success of Pathfinder, why not try an asteroid up and close and personal, right? NASA's NearEarth Asteroid Rendezvous Shoemaker, or Near Shoemaker for short, was designed to study asteroid 433 Eros, one of the largest asteroids in Earth's orbital neighborhood. It was not designed to land on it. I repeat, it was not designed to actually physically land on it. But after orbiting 433 Eros for nearly a year, snapping some 160,000 images along the way, and creating the first real body of data about asteroid composition and properties, the opportunity was too good for mission handlers to pass up. So they went ahead and did it. As it approached the end of its life in 2001, NASA mission handlers chose to attempt a landing on the asteroid's surface. Near Shoemaker continued snapping images all the way down, gathering pictures from as close as 400 feet that clearly resolved features the size of a golf ball. The spacecraft touched down, moving a mere 4 miles per hour on February 12, 2001, and continued transmitting data to Earth until the end of that month, making it the first spacecraft to successfully orbit, land upon, and transmit data from an asteroid, intended or otherwise. Following the incredible success of Mars Pathfinder, NASA crafted a Mars exploration rover mission around dual rovers launched in tandem in summer 2003 named Spirit and Opportunity. The 2 rovers were designed as robot geologists tasked with seeking clues to Mars' terrestrial and hydrological history. Both landed successfully on opposite sides of the red planet within weeks of one another in January of 2004 and began exploring, and they just kept going. Both Spirit and Opportunity have far outlived their 3-month planned lifespans by more than 24 times, returning from hibernation over and over again. Spirit's mission was finally terminated in March of 2010 after it failed to wake up from its hibernation state after more than 6 years of exploration. What is remarkable is that as of today, in January of 2018, Opportunity still continues roving and exploring the Endeavour crater and is preparing for another Martian winter. That is over 13 years of active exploration and transmissions back to Earth. Holy cow! So let's go further out into space now. Mars exploration is amazing, but the often forgotten Huygens probe could very well be the most interesting planetary lander humankind has ever sent into space. Carried by the Saturn exploring Cassini spacecraft for 7 years all the way to the outer solar system, the ESA designed Huygens was jettisoned from Cassini in January of 2005 and made the first and only spacecraft landing in the outer solar system on the surface of the Saturnalian moon Titan. Mission designers had very little idea what to expect for this landing, so Huygens was designed to land on both dry land or in an ocean. Ideally, it would transmit data for a few hours during its descent through the atmosphere, and if mission handlers were lucky, for a short time from the surface. Not only did it beam back 2.5 hours worth of data and images during its descent through the atmosphere, but after landing in the mud along a shoreline, Huygens beamed back data from Titan's surface for a full 70 minutes. A major technological achievement in space exploration and science. Now, NASA's NearEarth Shoemaker made the first landing on an asteroid, but it was the Japanese space agency's Hayabusa probe that actually lived to tell the tale. Launched in 2003 on a trajectory to intercept the asteroid Aikawa, Hayabusa landed on the asteroid's surface in November of 2005, collected samples from the surface of the asteroid, and returned to Earth, providing the only samples of asteroid material scientists have ever seen. But it almost didn't even happen. Upon landing on Aikawa, the projectiles designed to blast dust from the surface up into the Hayabusa's collection chambers didn't fire. Only the dust kicked up upon landing was available for collection, and the mission controllers had no idea if any of it had actually been contained aboard the spacecraft. For 5 whole years, researchers were left wondering whether Hayabusa had been a bust as they waited for it to make its return journey to Earth. Sure enough, their patience paid off. Hayabusa returned home 1,500 particles from the asteroid, marking only the 3rd time a space exploration mission had returned samples from another planetary body. With 2 robot geologists already rovering the Martian surface and a handful of orbiters overhead, NASA, along with several partners including the University of Arizona, which led the mission, sent the Mars Phoenix lander to a region near the Martian North Pole to search for environments suitable for microbial life and research the historical hydrology of the planet. And in May 2008, it landed and operated until November of that year. During the time, the stationary Phoenix lander examined deposits of underground water ice detected by the Mars Odyssey orbiter and found several interesting things hidden in the Martian soil and near surface ice, including evidence for the occasional presence of thawed water near the surface and traces of perchlorate, an oxidizing agent found on Earth that is a substance for some kinds of microbial life. The stationary Phoenix was never really meant to survive the Martian winter, however, though it outlasted its 3-month life expectancy by 2 months, as is tradition with Mars rovers. It sent its last transmission in November of 2008, and upon the return of sunlight to the region, the Mars Reconnaissance Orbiter was able to observe severe ice damage to Phoenix's solar panels. The mission was formally terminated in May of 2010. Now let's leave the red planet again to focus on another comet. After a 10-year flight to Comet 67P, the Rosetta orbiter safely arrived in August of 2014. Becoming the first spacecraft to orbit a comet, it successfully deployed its lander, Philae, in November of 2014. The landing, however, did not go as planned. Philae's harpoons did not deploy to attach to a surface. The lander drifted for more than 2 hours, periodically touching the surface before coming to rest on its side. Despite the unplanned bouncing, Philae completed 80% of its planned first science sequence before falling into hibernation in the early hours of the 15th of November, when the primary battery was exhausted. There was not enough sunlight in Philae's final location to charge the secondary batteries and continue science measurements. A month before its mission ended, Rosetta captured an image of the lander's grave, and proper connection was never fully established again, proving once again that space is hard, very, very hard. You may see a lander or orbiter here and there outlive all predictions and continue sending data for the rest of the time, but there will always be missions like the Rosetta and Philae that no matter how much time and money you spend on it, just doesn't work out in your favor, and that is space. It's hard. And for every successful rover mission we talk about here, there's 100 that failed, 100 that never left the ground, 100 that never left Earth or even got thought of, so it's hard. So, as we continue to our last and final rover in our history, after a number of largely successful rover missions to Mars, NASA decided to go big or go home and launched the famous Curiosity rover in November 26th of 2011. The car-sized rover is designed to explore Gale Crater on Mars as part of NASA's Mars Science Laboratory mission. After its first 2 years were a complete success, its mission was extended indefinitely in December of 2012. And since arriving at Mount Sharp in September of 2014, the robot has climbed about 600 vertical feet, drilling, sampling, and studying numerous rocks that are part of a geological division that mission scientists call the Murray Formation. With no one in sight, the Curiosity team continues to plan its way forward, drilling and photographing everything along the way. As Curiosity is still an amazing success, there's so many amazing cool things about it. Not only is it bigger than my car, but it has so many amazing tools that are used to observe Mars and its land, and it's so incredible to see what it's equipped with. with. If you want a better insight to seeing the Mars Curiosity rover, I ask that you go check out my friend Destin and his Smarter Everyday channel. He's got an in-depth look at the drill that's actually on the Curiosity rover with some pretty cool insight into how it actually works, what it looks like. It's incredible to see, so I ask you guys to go check that out and let me know what you think of that. So that'll do it for our History of Mars Part 2, and I hope you enjoyed that. That brings us up to modern day and obviously the Curiosity rover and the rovers that are still going today. It's incredible to see where we came from all these years, all the way back to the 70s, 60s, and before that. It's amazing to see what we can actually ship to planets, and as of today, we are weeks away from Elon Musk launching his car to Mars. So that's pretty cool. So guys, I hope you enjoyed that. If you did, I ask that you would click that subscribe button, click the like button, and even if you consider it, support us on Patreon. That really helps out a lot and really helps push out more of these videos as fast as we can. Again, if you liked it, let us know below what you want to see next. And again, we thank you guys so much for all the support, all the love, and everything you give to us. So thanks again for checking out Space Course, and we'll see you next time.